Here's problem 1310. The figure below shows a planet traveling in a clockwise direction on an elliptical path around a star located at one focus of the ellipse. When the planet's at point A, what's going on? So here's our star, and here's our planet at point A, and it's going around clockwise around this ellipse like this. And for such an orbit, we know that angular momentum is conserved, and the angular momentum is the mass times the velocity times the radius at any particular point in the orbit. So if it is constant, if it is conserved, then we would say that the mass times the velocity at one point times the radius at one point is equal to the mass times the velocity at a new point times the radius at a new point. Well, the mass of the planet is the same, so we simply have that the velocity times the radius is a constant. When one goes up, the other one must go down in order to keep it a constant value. So what's going on here? Well, let's consider a point where it was just previous to this. Let's call that point B. And the radius to that point we'll call our R1. And then our radius to point A then would be R2. And as we're going from R1 to R2, the radius is increasing. So our radius is going up as we're progressing from a previous point to where we are right now. And it continues to go up as we go to, say, point C, which is just beyond A. It's at the maximum value here. So the radius at that point would even be greater. Let's call it R3. So our radius is going up, which means that the velocity must be on its way down as we're proceeding through this point A. So as the radius is going up, the velocity is going down, such that the product of the two is a constant. Hence, the speed is decreasing as we are getting further away from the star, going clockwise around this orbit. So our answer is C.